Hi everyone, in this video we want to get started on log properties. So I just want an intro video to walk through what the log properties are. Basically, logs represent exponents, so all of the log rules are really exponent rules. We just have to figure out how to rewrite some of our basic exponent rules that I hope we're comfortable with in terms of logs. So I'm going to start with two exponential statements, statements involving exponents, u equals b to the x and w equals b to the y. So I want to keep the base the same. The log rules involve logs with the same base, but I want a couple different combinations of powers and outputs. So first I'd like to rewrite each of those as log statements, and then I'll start to compare the log info with the exponential info down below for different properties. Okay, so if u is equal to b to the x, then the log base b of u should equal x. And if w is equal to b to the y, then the log base b of w should equal y. So this is just our standard rewrite an exponential statement in log form thing. Okay, so excuse me, first exponent rule I want to look at is multiplying two exponent statements with the same base. So if you multiply a b to the x times a b to the y, hopefully we remember this one, this is a b to the x plus y. If you're multiplying two things with the same base, you should add exponents. So there's the exponent rule. I now want to rewrite this thing in log form, so get as much log information as I can. So let's go ahead and just rewrite in log form. This is an exponential statement with a base of b, so we should be able to write this as a log base b of the result u times w is equal to the power x plus y. And then I actually just have one more step. Up above we found that x was actually a log base b of u, and y was log base b of w. So the log property that goes with adding exponents is that the log base b of u times w is the same as the log base b of u plus the log base b of w. Running into my territory for my next one. So this is log property number one. Again, the exponent property is if you're multiplying two things with the same base, add exponents. And here in the log property, it says if you're looking for the power of b that will give you the product, you should add the powers of b that give you u and w. So it's that same property. Multiplication with the same base means add exponents, but it's rewritten with logs. All right, next property that we want to look at is division. So if we divide two exponent statements with the same base, the exponent rule, which again I hope we remember, is subtract exponents. So u over w is equal to b to the x minus y. And then we want to rewrite this as a log statement. So I'm going to say that the log base b of the result, u over w, should equal the power x minus y. And then once again, we want to rewrite the x and y in terms of their logs. Log base b of u minus log base b of w. So property number two is the log of u divided by w is the same as the log of u minus the log of w. So the log of a product is equal to the sum of two logs. The log of a quotient is equal to the difference between two logs. And pay careful attention to the fact that these work both directions. So if you're ever adding two logs together with the same base, you could actually combine them into the single log of a product. And if you're subtracting two logs with the same base, you could combine them into the single log of the quotient. So be really clear on which direction splits something into two logs and which direction combines it into one log, because that a lot of times is the whole point with these two properties. Okay, last exponent rule we want to look at. We'll see if I can squeeze this in this little space. If we take something to a power and we raise it to another power, the exponent rule says we should multiply. So we will get, I'm debating if I want to write this in a special order. I think I'm going to write it p times x. X times p times x doesn't matter. I think I want it to end up being p times x. If I want to rewrite this as a log statement, it's going to be a log base b of the result, which was u to the p, is equal to the power p times x. And then x again is equal to a log. So it looks like what we're getting, I'm going to write it down below, number 3, is that the log base b of u to the p, and to be really clear, this is u to the p inside the log. The rule doesn't hold if it's the entire log of u raised to the p, is p times x, and x was the log base b of u. So this one I find that people do not have so much trouble remembering. The first two, yes, people have trouble remembering those. They get them wrong, so make sure you really work on just straight up memorizing what these say. This one, people are really good at just seeing, okay, if there's a power in here, I can drop it down in front. If there's a number in front, I can move it up into the power. So I would just say the only thing to be careful about is the thing that I was mentioning before, that the log base b of u to the p is not the same as log base b of u all raised to the p. So this property does not hold for the entire log raised to a power. That's a different thing. All right, there's one more, and this doesn't always get classified as a log property, but it's kind of the same idea. We want to be able to change the base of our log. Sometimes we start with a log base 2 and we would rather have a log base 10. Sometimes we start with a natural log and we'd rather have a log base 5. So we want to be able to do that. So I'm going to start from scratch here. I'm going to say that the log base b of w equals y is the statement that I'm working with. And I don't want to just rewrite it in exponential form. I want to rewrite it with logs with a base of c. But my first step is still going to be to rewrite it in exponential form. So first I'm going to get rid of the log base b by writing it in exponential form. And then I'm going to go ahead and take the log base c to introduce that in. So exponential form of this would be b to the y equals w. And then if I want to take the log base c of both sides, which is a perfectly legal thing to do, just like square rooting both sides of an equation or squaring both sides of an equation, we want to be a little thoughtful and careful about it, but it is legal to take the log of both sides of an equation. And let me be careful here, particularly I wanted the log base c. So I end up with this statement. And what I'd really like to be able to conclude is that the log base b of w is equal to something that involves log base c's. So I'm going to go ahead and solve this for y, this down here for y, because if my original thing was equal to y and I get something new that's equal to y, those two things have to equal each other as well. What I get to do is take advantage of property number 3 that I just got. Let me make sure this is really clear. This is a p times. So I move the y down in front. And it's y times the log base c of b equals the log base c of w. I guess we can keep parentheses either way there. And then because this is attached by multiplication, I'm going to go ahead and divide. I get y is equal to the log base c of w over the log base c of b. So putting these two together, if y is equal to both of those things, then those two log statements need to equal each other, which means the change of base property says the log base b of w is equal to the log base c of w over the log base c of b. This is the change of base formula. And this one really messes with people sometimes. So I'm just going to tell you how I say it to myself to try and remember it. So really quick example here. If I have the log base 2 of 7 and I want to rewrite using, I don't know, log base 10, pick your log, plain old common log. What the change of base formula says is that if you want to change from one log base to another, you just go ahead and do it. So I went log base b of w and I turned it into log base c of w. But you're not done. So I'm going to go ahead and turn this into common log of 7. So the input stays exactly the same. You switch the base to whatever you want it to be. To correct for the new base, you have to divide this thing you end up with by the new log, the log base c, so for us that's the common log, of the old base, which was 2. So this is b. So again, I am just using formulas, but this one is a little tricky for people. So if you want to convert from log base B to log base C, just go ahead and do it, and then make sure you divide by the new log of the old base. Oh, sorry, move that up. Thanks for watching.